Okay, so hopefully you successfully completed all 3 parts of this experiment. I'm going to continue on where I left off in the lab video with part 1. So I'm going to combine the reactants. So here's my 1 gram of baking soda and 28 grams of vinegar. Just going to dump that in. It's fizzing like I'm sure you saw. And 3B says wait until the reaction is finished and observe the leftovers. What do you see? What do you smell? And the cool thing is you kind of know when the reaction is done, when it stops making a sound and fizzing and bubbling. So it clearly still has vinegar in it, which is interesting. So if you put excess vinegar to start out with, it looks like there's leftover vinegar. If there is leftover vinegar, I'm guessing that for step 5, if you add more vinegar, it won't react. But for step 4, if you add more baking soda, it will react. So let's do step 4, add a small pinch of baking soda, less than a gram of solution, and notice if it reacts. So I'm just going to get a tiny amount of baking soda, just barely, just not even 1/8 of a little spoon here. Okay, I heard it, I see it bubble, fizz, and react. It was a tiny amount, it was a tiny reaction, but that's because it was just a tiny bit of baking soda. Okay, so step 4, write down, if this is what you got, hey, a little bit of baking soda still reacts with the solution. Now, and I'm hypothesizing this will not react because I think we used all the baking soda. So there's nothing left for this to react. Yep, interesting. So in part 1 where we used lots of vinegar to start out with, there's still vinegar in there. If I put more vinegar in, there's nothing for it to react with. All the baking soda's gone. So that's all I've completed part 1. Okay, now I'll do all of part 2. Now just for like part 1, let's dump the baking soda in. The key thing I think to look for in part 2 relative to part 1 is what's left over. Is there vinegar left over? Is there baking soda left over? Okay, so the one with more baking soda, 3 times as much baking soda, 3 grams, and relatively less vinegar, from 28 down to 14, is white and cloudy. And okay, so one clear difference is if you have more baking soda, you might have some baking soda. I have some baking soda left over, and actually I can see some white powder now forming on the bottom of the cup. So clearly baking soda is left over. There's excess baking soda. Let's do step 4 and 5 again. So 4, and again, I'm betting more baking soda will not react because there's all the vinegar theoretically has been used up. Yep, and I put in, I'll even do a little more. No reaction. So there must be no vinegar. We used all the vinegar, but there is baking soda. So, and this is interesting, it's suggesting maybe that there is a perfect ratio. Okay, a little bit of, okay, slight, but it was just a slight amount of vinegar, but it was a slight reaction with a little bit of bubbles. Yep. Okay. So clearly, in this reaction, there was excess baking soda. Very interesting stuff. So on the landing page, you can see all of our results and the data that we collected. It's all in line with the observations and things I was saying when I was actually running the experiment. Let me jump to the QC lab conclusions. So through these experiments, we deduce that chemicals cannot combine in just any random amount. When we react a lot of vinegar with a small amount of baking soda, we have excess vinegar, and we know that because it still smells like vinegar and all the baking soda is gone. When we have excess baking soda, we used up all the vinegar, and we know that because when we put more baking soda in, there was no reaction, so all the vinegar must have been gone. So this leaves the question, is there a special ratio a recipe, one might say, that produces no leftovers of the original reactants. So this brings up the hypothesis of constant composition. And again, I'm just reading off the landing. Proust, exhausted but relieved after hours of experimentation, sits with a thud to his recliner by the window and basks in the warm light of the late morning sun. His stomach grumbles. The breakfast bakery is calling him, but he takes a moment to collect his racing mind and jot down the results of his experiments. He is feeling cautiously excited. The results just may indicate he is right. There may be a unique ratio of amounts of chemicals that can react to form other chemicals. This is what he knows. If you start out with too much of chemical A, you end up with excess leftovers of chemical A. It is as if there was not enough chemical B to react with chemical A. Kind of makes sense. If you start out with too much of chemical B, same thing, you end up with an excess and leftovers of chemical B. It is as if there was not enough chemical A to react with all of chemical B. So is there a perfect unique amount? Is there a perfect amount of A and B such that nothing is left over? This is the question. This is kind of like his quest, his hope that he could find. He reasons that if no reactants are left over after the reaction is complete, this is indicative that you have found the perfect ratio. He thinks to himself, we must find this ratio.